first question says you arrange y plus 3 equals to x times y plus 2 to make y the subject of the formula. So we'll begin with expanding the brackets on the right-hand side. So y plus 3 equals to xy plus 2x. Next, what we're going to do is we're going to collect all the terms with the variable y on one side. The reason being is that we're trying to make y the subject of the formula. So it's important that every single term that has the variable y attached to it, it's on one side. So that means we'll take xy to the left-hand side and 3 to the right-hand side. So we'll have y minus xy equals to 2x minus 3 now. Now we're going to take y common on the left-hand side. So that's y bracket 1 minus x equals to 2x minus 3. Now we make y the subject by dividing 2x minus 3 by 1 minus x. And that is your answer. As you can see, initially we had y on both sides. But once we expand the brackets and collected the y terms on one side, we could easily take y common and make it a singular term. And now, as you can see, as we progressed, y was alone as a subject on one side, and everything else was on the other side. In the next question, it says that we have a vector AB, which is 2, 4. We have to write down a vector that is perpendicular to AB and is twice its length. So something perpendicular to AB can be this vector over here like this. So if we had all of the boxes, it would have been easy for you to understand. Horizontally, we're going 4 units to the right. And vertically, we're going 2 units down. So the perpendicular vector is going to be 4, negative 2, because negative 2 because we're going 2 units down, and positive 4 because we're going 4 units to the right-hand side. Now it says that it is supposed to be twice the length. So we multiply 2 with this vector, and that's going to give us 8 and negative 4. That is your answer. In the next one, it says work out the probability of A complement intersection D complement. So A complement is going to be everything that is not a part of A. And D complement is going to be everything that is not a part of D. So if you think about it, that's going to be this part over here. In order to make sure that we're not missing out any values, I'm going to add all of these probabilities and see if they add up to 1. Because if they don't, that means there's something outside over here as well. So we're going to add 0 0.09, 0 0.11, 0 0.1, plus 0 0.2, plus 0 0.13, plus 0 0.07, and plus 0 0.18. Now this adds up to 0 0.88, which is less than 1, which means over here, if you subtract 0 0.88 from 1, that's going to be 0 0.12. There's something outside over here, which is the probability of whatever like the event happening over here is, that's not a part of A, B, or D. So that's 0 0.12. So our probability for the intersection of A complement and D complement is going to include this as well. So we're going to do, let's separate this over here, 0 0.13 plus 0 0.12, which is going to be 0 0.25. That is your final answer. So remember to always check if like they've missed out any values, like add up all the probabilities that are given, subtract that from 1, and see if like there's something that's supposed to be outside as well. Because we could have easily missed that out, and we could have easily just used 0 0.13, which would have been proven to be incorrect. So always make sure that you have all of the values and then give the final answer. Next question says factorize 14x squared plus 31xy minus 10y squared. Now this is also a quadratic equation because the highest power of the variable is square, which is 2. Now I know you must be thinking, oh, so there's an x and y written together. The steps are exactly going to be the same as you have learned for factorizing a quadratic equation. The only thing different now is that you have two variables instead of one. So what we'll do is first we'll multiply 14 and 10, which is 140. So now we find factors of 140. That's going to be 70 times 2, 20 times 7, and 140 times 1, 35 times 4, and 28 times 5. I think that's about it. So once we've listed out all of our factors, we pick that set of factors, which when added or subtracted gives us the middle term. So we know that 35 minus 4 is going to be 31, which means we will pick this set of factors and we will use this to replace 31xy. So now we're going to rewrite this as 14x squared plus 35xy minus 4xy minus 10y squared. As you can see, we replaced 31xy with 35xy minus 4xy, which is the same as you would have done with the quadratic equation that had just one variable. So now what we're going to do is, we're going to split this into two groups and factorize it separately. So first two terms make one group and the last two terms make another group. So between 14x squared and 35xy, we have 7x common. So we'll have 2x plus 5y inside the bracket. And between negative 4xy and 10y squared, we have negative 2y common. So that's going to be 2x plus 5y again. So now we're going to take 2x plus 5y common from both 7x and negative 2y. So 2x plus 5y times 7x minus 2y. And this is your fully factorized answer. Next question says, after reduction of 3% in the original price, a motorbike is sold for 700 pounds. Both of these values are correct to one significant figure. Calculate the greatest possible original price before the reduction was applied. So we know that they're all correct to one significant figure. So we will do for the percentage 1 divided by 2, which is going to be 0.5. So for the upper bound for the percentage, that's going to be 3 plus 0.5, which is 3.5%. And for the lower bound for the percentage, we'll do 3 minus 0.5, which is 2.5%. Always remember you begin with dividing the degree of accuracy by 2, and then you add or subtract that value from the original value to get the upper bound and the lower bound. Since our degree of accuracy is correct to one significant figure, so for the percentage, we do 1 divided by 2. And for the price of the motorbike, we will do 100 divided by 2, which is 50. Over here, we're doing 100 divided by 2 is because the price is 700 pounds. So 100 pounds is one significant, correct to one significant figure as well. So 100 divided by 2 is 50. And then for the upper bound, we'll do 700 plus 50, which is 750 pounds. And for the lower bound, we will do 700 minus 50, which is 650 pounds. Now we have to calculate the greatest possible original price before the reduction was applied. So 700 is basically 97% of the original price. But since we're talking about the greatest possible value, that means our percentage is going to be 96.5% of X, the original, equals to 750. Why? Because over here, if you write this, it's going to be 750 over 0.965 because you move the decimal 2 places to the left. And the reason why we're writing 0.965 and 750 is because we want the greatest possible value. And the greatest possible value is only possible in division if the numerator is the upper bound and the denominator is the lower bound. Hence, for the price of the bike, we chose the upper bound. because that is going to be divided by the percentage, and that's going to be the lower bound. So 750 divided by 0.965 is going to give us 777.20 pounds. That is the greatest possible original price before the reduction was applied.